Okay, back to work. So on the previous video, I had stopped right here where I had factorized 108. So actually, why do I have an equal sign there? So this should say log base b. Here, let me separate those. Log base b of 2 squared times 3 to the third. So I'm expanding this to log base b of 2 squared plus log base b of 3 to the third. Now I can bring my powers down front, use my power rule, bring these down front. So I get 2 log base b of 2 plus 3 log base b of 3. Now I can substitute in for my logs. Log base b of 2 is p, so I get 2p plus 3 log base b of 3 is q. So there is that one. Okay, next one, solve for x. I notice that 25 can be rewritten as 5 squared. So 25 is 5 squared, and I still have 1 minus x in my exponent. And 125 can be rewritten as 5 to the power of 3. And I want to get these written with the same base, so I'm going to change this to 5 to the negative 3. And I'm going to go ahead and distribute that. So 2 minus 2x is equal to 5 to the negative 3. Okay, so if you have something in the denominator and you want to move it, just make the exponent change its sign. Okay, so now that I have the same base, I can set the exponents equal to each other. So 2 minus 2x is equal to negative 3. Minus 2, I get negative 2x is equal to negative 5. Divide both sides by negative 2. I get x is equal to positive 5 halves. So there is that one. And then the next one, I am going to solve it just like I would normally solve it, trying to get x by itself. So I'm going to minus 5 from both sides. And that leaves me with 3 to the x plus 2 is equal to 9. And then 9 can be rewritten as 3 squared. So notice they have the same base. So now I can set the exponents equal to each other. So x plus 2 is equal to 2 minus 3 from both sides. And I get x is equal to negative, wait a minute. Why did I make that a 3? That's a 2, sorry. Minus 2 from both sides, and I get x equals 0. Okay, so I could also go back and check that. If I put in 0 for my x, 0 plus 2 is just 2. 3 squared is 9. 9 plus 5 is 14. So it makes sense. Okay, I could do the same thing here. This one would be a little bit harder. 1 minus 5 halves. So if I do a check, 1 minus 5 halves. Well, 1 is the same as 2 halves. Minus 5 halves is equal to negative 3 halves. So I have 25 to the negative 3 halves. Oh, this check is getting out of control. 25 to the negative 3 halves. I get rid of the negative by making it a fraction. 25 to the 3 halves. 25, let's see, 25 is the same as 5 squared times 3 halves. The 2's cancel out, and I'm left with 1 over 5 to the third. Okay, so that check is maybe a little too cumbersome. But anyway, it works. 1 over 5 to the third is the same as 1 over 125. Okay, so that you don't have to do a check. I'm just showing it is possible to check your answers and see that you got it right. So let me go ahead and back that out. You don't have to do the check. That took too much space. All right, so the next one, the population of bacteria increases in size by 25% every hour. Okay, so this is my rate. So this is one of these R problems. So I'm going to have my starting amount is 1,000. So this is exponential. We've got exponential growth when it's growing by a rate. So I have 1,000, and it is increasing in size. So it's 1 plus R, and R is 0.25, because we changed that to a decimal, so 0.25, and that would be to the x, or I could put t. Okay, so I could say, f of t is equal to 1,000 times add these together, 1.25 to the power of t time. Okay, so there's my formula, and then I am going to use that to figure out how much bacteria I'd have after 2 hours. So letter I have 1,000 times 1.25 squared, and that one, this one I would have to use a calculator for. So far I haven't used my calculator for any of these, have I? I don't remember. Yeah, I haven't used a calculator at all. So this one, though, I would definitely need to use a calculator. I do not want to have to multiply out 1.25 times 1.25. So if I do this, I get 1,000 times 1.25 squared, and that gets me approximately 1,560 if I round it off to 3 significant figures, and that's bacteria. Okay, and then for double I, 1 day, well, 1 day is equal to 24 hours. So my t is going to be 24. So f of 24 is equal to 1,000 times 1.25 to the 24. Again, I'm going to use my calculator. 1,000 times 1.25 raised to the 24th power. And if I round that to 3 significant figures, I get approximately 212,000 bacteria. Okay, next problem. So that's an ugly looking thing, but we can do this. Well, the first part, we can do the first part without a calculator, or you could use your calculator, but I'm going to go ahead and do it without a calculator. To find the y-intercept, you change x to 0. Make x equal to 0. That's how we find the y-intercept. Zoom in a little bit more here. So I'm going to get f of 0 is equal to 2.5 to the 0 power over 5 times 0 minus 10 plus 3. Anything to the 0 power is equal to 1. 5 times 0 is 0. 0 minus 10 is negative 10 plus 3. So that's equal to, so if I 3 minus 1/10, that would be 2 9/10. So that is my y-intercept, or I could write that as a decimal. That would be 2.9 exactly. Okay, I don't have to put a 0 after that because it's actually an exact answer. I'm not rounding it off. All right, so my y-intercept would be 0, comma 2.9. Find the equation of the vertical asymptote. You get a vertical asymptote when you make set the denominator equal to 0, because that's something you can never have x a number so that the denominator equals 0. You're not allowed to divide by 0. So if I solve this, I get 5x is equal to 0. I'm sorry, it's 10. Add 10 to both sides. Divide by 5, and I get x is equal to 2. So my vertical asymptote is at x equals 2. It's got to be an equation. You can't just write 2. You will not get any points for just writing the vertical asymptote is 2. It's got to be the equation of a line. All right, find the minimum value. And I gave you a hint. This is a calculator question. Okay, so we're going to grab our calculator, and we're going to go in here, and we're going to type in the entire thing. So 2.5 raised to the x, and the whole thing divided by, I'm going to put this in parentheses, 5x minus 10, because all of that has to be in the denominator. Then I close my parentheses, and then plus 3. And I'm going to go ahead and graph that. And whoa, my window looks weird. So let's do this. Let's do a zoom 0 and see what happens. Here it comes. Oh, I don't like that either. Let's do a zoom 6, standard. See if that helps. See, since I don't really know what this graph is going to look like, I'm not sure how to set my window, so I kind of just play around with it. Okay, so there it is. Now, I want the minimum value of f of x when x is greater than 2. Well, 2 is where my vertical asymptote is, so that's right here. So if I want x to be greater than 2, I'm talking about this portion over here. So since I'm using my graphing calculator, I have to draw a sketch of my graph. It looks like it's something like this, and the minimum value is going to be right there. So now I'm going to do second calculate I'm going to use the minimum. And I don't want this one. I want this one over here. So I'm going to use my arrows to move over there. Up, there I am. So it says left bound. I want to be on the left side. And then move to the right side of that minimum. And ask it to guess. And I don't have my glasses on, but I wrote this down before. It's the value means y. Okay, the value means y. So what does y equal right here? Y is equal to 6.11. Okay, so we don't want the whole coordinates. When it says value of f of x, that means y, because f of x means y. So what's the y value? There it is, 6.11. Okay, next one, f of g of 1. So since the 1 is closer to the g, we're going to put the 1 into the function g. So g of 1 is what we're going to do first. So g of 1 is equal to negative 2 times 1 squared plus 8. So I get negative 2 times 1 is just negative 2 plus 8. That gives me 6. Now I'm going to take that and I'm going to plug it into the other function. So now I'm going to do f of 6. So 4 times 6 minus 2. So I get 24 minus 2 equals 22. So f of g of 1 is equal to 22. Okay, inverse function. So I'm going to take this function. When I do the inverse, I'm swapping the x's and the y's. Swap the x and the y's for an inverse function. So instead of y equals 4x minus 2, I'm going to say x equals 4y minus 2, and now I'm going to resolve it to get the y by itself. So I add 2 to both sides, so I get x plus 2 is equal to 4y. Now I'm going to divide both sides by 4, so I get y is equal to x plus 2 over 4. Oh, instead of saying y equals, we'll change it back to f negative 1 of x, so that I know that is in fact the inverse of f of x. There's the inverse of f of x. Okay, the next one, g of f negative 1 of x. So I'm going to take that f of negative 1 and I'm going to put it inside of g. So here's my f negative 1. I'm going to plug it in for the x in the g function. So I'm going to write negative 2, and then where the x is, I'm going to plug in this whole thing, x plus 2 over 4, and then that's squared plus 8. And that's it. You don't have to simplify it. You can just leave it like that, because it just says write an expression. It doesn't say it has to be simplified. So I'm good. All right, next question. Okay, this one is really complicated. I did not leave nearly enough room to do this one. So I'm going to do this on another piece of paper. So I'm going to take a break and get another piece of paper.